Hi guys, Ms. Malik here. Today we're looking at exercise 6D from your Essential Methods textbook. We're looking at further symmetry properties of the unit circle. So here we have the unit circle and we have theta drawn in the black triangle, and I've illustrated there where we do negative, the negative theta, so I've put that in red. And what we can see here is that cos of negative theta is going to equal cos theta, because remember that the cos value is your x value, and your x value still is the same right there. So now if we look at sine of negative theta, so just say we have negative theta here and we put the sine of that, which is going to be your y value. So right at that point there, well, that's just going to be the negative of whatever sine theta was. So theta, of course, will be the same angle. And if we put the angle here, just say this was 0.3, then down here would be negative 0.3. When we look at tan of negative theta is negative sine theta over cos theta. And that will give us negative tan theta. Moving on from there, we see if we have sine theta equals b, so in my diagram there, I've got theta being the angle and sine being this length here. So sine theta is b and cos theta is a. Let's remember that for the next thing we're going to do. So I've drawn it down here so you can keep remembering that. Here is pi on 2. As you know, pi is halfway around the circle, and therefore pi on 2 will be just a quarter of the way around the circle. And we're going to look at sine of pi over 2 minus theta. So here, I've taken my angle that I have down here in the smaller unit circle, and then I've just put that angle the other way around. So I'm putting it so it's the same angle. So just say it was 45 degrees in the lower circle, it's going to be 45 degrees in this circle here. What we can see then is that B is going to become the top length there, and A is going to become our left-hand side length. So if that's the case, we can say that sine of pi on 2 minus theta, so this here, so we've got this angle here, which is sine of pi on 2 minus theta. And the length for sine is going to be, well, it's going to be A, isn't it? Because as you can see, it's the same. I've drawn that in blue, so it's easy to see. So the rule there is that the sine of pi on 2 minus theta, so the sine of this, here demonstrated by this purple arrow, is going to be the same as A. And there's A right there. And referring to our lower triangle, we can see that A is actually cos theta. So sine of pi on 2 minus theta is cos theta. That's an important rule to remember. Let's now look at cos of pi on 2 minus theta. So cos is, of course, our horizontal length, and it is the B. It's B here. So what we can see there is that cos of pi on 2 minus theta, so your x value is b, which is the same as what sine theta is. So note that because we've turned the triangle around, we can have these rules and relationships. Let's move on from there. And now we're looking at sine pi on 2 plus theta. So as you can see, sine pi on 2 is, of course, that part there, and then we're adding on pi. So there it is there. That's the angle we're looking at, sine pi on 2 plus theta. Now remember, we still have that little unit circle down in the left-hand side to remind us what pi and A and B originally were. So remember that sine theta was B and cos theta was A. So now we can say, with this angle of sine pi on 2 plus theta, our A value is going to equal cos theta, because A, being our sine value of our new pi on 2 plus theta, is the same as A in our bottom unit circle, being cos theta. So the rule is sine pi on 2 plus theta is equal to cos theta. How about cos pi on 2 plus theta? So again, here's the angle, pi on 2 plus theta, and our cos value is our b length there. So it's the x value, and it's going to be a negative value there, and it's going to be the negative of whatever b was or is. So if it's the negative of b, remember that before we flipped our triangle around, b was sine theta. So that means that cos pi on 2 plus theta is the same as negative b, which is the same as negative sine theta. These are useful relationships to know, and you'll see why in this example. So here we're looking at if sine theta equals 0.3 and cos theta equals 0.8, we want to find the value of sine pi on 2 minus alpha. So we're looking, here is alpha, in the cos alpha is 0.8, and look what they've given us. I've shown here the unit circle, and I've shown that we have a triangle with an angle of alpha there, and cos alpha is 0.8. So that means that this length, this x value length, is 0.8. So let's think about now what sine pi on 2 minus alpha would be. Pi on 2 is here. Here's our little unit circle showing the original information. Now let's put the information of pi on 2 minus alpha. So let's flip that triangle around so that we get alpha in there. And we can see that 0.8 now exists as our vertical length there, because we flipped that triangle around. Look at the relationship between the bottom left-hand unit circle and the big unit circle over here. So therefore it makes sense that here is pi on 2 minus alpha, and we're looking for the sine value of that, which is this point here, and that's the same as the blue line here. So the two blue lines are going to be equal in length, meaning that sine pi on 2 minus alpha is going to be 0.8. Once you get to know these relationships off by heart, you don't have to draw the unit circle each time. You will just know that sine pi on 2 minus theta is the same as cos theta. Let's do another one. So here we're going to say if sine theta is 0.3 and cos alpha is 0.8, we want to know the value of cos pi on 2 plus theta. So here's the unit circle, and I'm drawing in the original information that I need. We're dealing with theta, so I'm going to draw the triangle with theta, and we know that the sine of theta is 0.3. There it is there. Now, let's now put that in the left-hand corner so we can see that and refer to it if necessary. Here's the unit circle again. Now let's flip that triangle. Let's take it and put it over here, because we're saying pi on 2 plus theta. So we're adding the theta on over here. So it's in addition to our pi on 2 value. Now remember that because we've flipped the triangle around, our 0.3 is going to flip as well. Here it is here, and we're looking for the cos value of pi on 2 plus theta. So we're looking for whatever this x value of the coordinate will be here. There's our angle. And of course, this blue line here represents what was sine theta, which is 0.3, has now become cos theta, or cos pi on 2 plus theta. So that means that cos pi on 2 plus theta is going to be negative 0.3. Look how it's in the negative zone. It's over here. It's a negative value for your x. Let's now try if we've got sine negative theta with the same values. So there's our unit circle, and we're looking at theta again, so we put in the 0.3. That's all we've got for theta. We can't put in 0.8 because that's when the angle is alpha, so it's irrelevant for this question. So sine negative theta being we want to find, and I've put the information of theta and 0.3. Let's put that unit circle down there so we can refer to it, and I'm going to flip that angle around to put it as negative theta. There's my theta there. I'm trying to find my sine value. It's over here, and whatever that value is here has got to be the same as 0.3 but negative. So if that's 0.3, then sine negative theta must be negative 0.3, as we can see from the rule. All right, that's the end of 6D, so the further symmetry properties. The next thing we do is the exact values.